Hi guys, in this video we are going to learn different ways of extracting data from Salesforce using Azure Data Factory. The first thing we need to do is to create a linked service. So we have here the Data Factory resource. We are going to the Manage area, Linked Service, New, and here we need to look for Salesforce. We are just using the standard Salesforce in this case, so we are going to pick this one. We are going to keep the same name, and we need to supply the following values: the URL, the client ID, the secret, and the API version. I don't have direct access to the Salesforce environment to show you how to configure the app, so apologies for that. But down in the description, you will have a link with all the steps that you need to follow in order to get the client ID and the credentials. Okay, so let's continue. I have already added here the values. You can see the URL, the client ID, and the credential, and also the API version. And we are going to test the connection. Okay, as you can see, it's able to reach Salesforce. The next step is to create a dataset. We need to go to the authors area, dataset, new one. We are going to look for Salesforce. Yes, this one. And we are going to keep the Salesforce object one as the name. And here we need to select the Salesforce linked service that we have just created. We are going to keep the object API and click OK to create the dataset. Okay, so if we now open the dataset, we will be able to open the Object API combo to see the different tables that we have there. Let's do something. Let's create a new pipeline. We are going to add a copy activity, and in the source we are going to select as dataset the one we just created. Here we have two options. We can use the Object API, that is the same that we saw in the combo previously, or we can use a SOQL query to extract the data. I have been playing around with both of them, so I can give you some pros and cons that I found when using each approach. So for the Object API approach, in this method we just define the entity that we want to export, and Salesforce creates the necessary request to get the data. The pros are that this method uses bulk operations, so no limit on data extractions per request. I have been able to extract more than 6 million rows in a single request. Queries are also automatically built, so there's no need to worry about constructing them. And as a cons, we can't use parameters to filter the data, so building incremental loading is not an option. We will need to extract the whole table on each run. Okay, we go now to the SOQL approach. In this method, we need to create a query specifying the entity that we want to export and all the columns. The pros that we can pass parameters in a where clause, so we will be able to use this for incremental loading. And as cons, we need to build the query ourselves, specifying all the columns, as select star is not supported in SOQL. Also, there is a limit of 2000 rows per request, so multiple requests will be needed in order to get the latest delta. Let's review some pipelines I have prepared to review the two approaches. For the Object API approach, I have created a dataset. In the dataset, I have created a parameter called Object API that I'm using here to define the Object API value. If we move to the pipeline, we can see that here we have a lookup task. This allows us to get the list of tables in Salesforce. We can see that I'm using a SOQL here, as this task is getting the whole list of tables in Salesforce, and I'm querying the table entity definition that contains all the tables in Salesforce, and I'm just looking for queryable tables. And also I'm limiting the output to 2000 tables. As we already mentioned, we have a limit in the output, so if it's bigger than that, it will fail. We can run a preview just to see the data. Okay, and here we have some of the tables. Now, with the output of this task, we are going to get into a for each loop that will iterate for each of the tables. So here, in the settings, we are capturing that output. And if we get into the for each loop, we have a copy activity, and in the source, we have added the item value for each operation that will contain the table name. And in this case, our destination is going to be a blob storage. Here in the file, we are also using the item value parameter so that we can have a Parquet file with the same name as the source table. In this case, the pipeline extracts all the tables from Salesforce, but of course, we can also filter those in which we are interested. In the case that you also want to do a full extract of the tables and you have more than 2000 tables, as is my case, the only programmatic approach that I found was to do this process 2 times. In the first run, we will query the first 2000 tables ordered by the qualified API name ascendant, which is the name of the table. And in the second one, the order by will be with the same column, qualified API name, but in this case, in the descending order, and limiting the query to the number of tables that are pending. Okay, in fact, with this pipeline, we already covered both the scenarios, the Object API and the SOQL approach, but I will show you something I also work on in case that this is useful for you. Other than this entity definition, there is another table where you can get the list of columns of each table. This table is called field definition, but it's a bit particular as it requires always to receive a where clause with the table name. This means that we need to query it for each of the tables. For that purpose, I created this pipeline that contains again the same lookup activity querying the entity definition, then a for each loop getting the output, and inside, in the copy activity, a query where we use the table name, but in this case, querying the field definition table. If we check the sync area, I'm storing this into a columns file, and the path contains the table name. Let's move now to Databricks, where we will be able to see the structure. So here, in the tables folder, we have a folder for each table, and inside we have a Parquet file with the columns. Then in Databricks, I created a notebook to append all this data together and also include the table name from the path. And with that, I'm able to create something like this that is a kind of control table. Here we have a column where I was able to construct the SQL queries that we need to run. And in case that the column last modified is contained in the query, I'm also creating the structure of the incremental load. And here we have the where clause. So in Data Factory, we can dynamically replace the value. With this control table, instead of going to the Salesforce to get the list of tables, I can come to the Databricks and extract all the queries that we need to use in the SOQL approach and do the incremental load. And that's mainly it. I hope you found this video useful and thanks for watching.